This is lesson 3.3 on function notation. Function notation is just a fancy way of writing y. So our essential question here is, how can you use function notation to represent a function? Well, you know that linear functions can be written in the form of y equals mx plus b. By naming a linear function f, you can also write the function using function notation. F of x, that's how it's said, equals mx plus b. F of x equals mx plus b. The notation f of x is another name for y. If f is a function and x is in its domain, then f of x represents the output of f corresponding to the input x. You can use other letters other than f to name a function, such as g or h. You'll often see those letters used. So let's look at our example. Evaluating a function. Evaluate f of x equals negative 4x plus 7 when x equals 2 and when x equals negative 2. Now to solve this here, I'm just going to rewrite this here. F of our x here is going to be 2. So what is f of 2? Remember, this is just basically saying what is y. Don't think of this as f times 2 or anything like that. So we're just going to take our negative 4 times 2 plus 7. So f of 2 equals negative 4 times 2 is negative 8 plus 7 is going to give me f of 2 equal to negative 1. Now let's go ahead and do f of negative 2. Now I just put a negative 2 in here. And again, I'm just subbing in negative 2 for my x. So negative 4 times negative 2 plus 7. Let's figure out our math here. We just rewrite that f of negative 2. Negative 4 times negative 2 is going to be a positive 8 now, plus 7. So f of negative 2 is 8 plus 7, which is 15. That's evaluating a function when we're given the x variable. So let's look at another example here. Interpreting function notation. So we're going to let f of t be the outside temperature, Fahrenheit, T hours after 6 a.m., explaining the meaning of each statement. So f of 0 equals 58. So basically what this is saying here is the initial value of the function is 58. So the temperature, right here, the temp at 6 a.m. is 58 degrees Fahrenheit. That's what that is telling us there, because it says f at 0, 0 being the time, the hours after 6 a.m. Well, 0 hours after 6 a.m. is still 6 a.m. How about our B here? The output of f when t equals 6. So, the temperature at noon, because that would be 6 hours after 6 a.m. So at noon, temp is in degrees Fahrenheit, right? A number's not given, but it just says that at f of 6, it's in. So it's in degrees Fahrenheit at noon. And now our last one here, we have the f of 3 is less than the f of 9. Well, f of 3, that means 3 hours after 6 a.m. So that 3 hours after 6 a.m. is going to be 9 a.m. And f of 9, that's going to be 9 hours after 6 a.m. or 3 p.m. So this is telling us that the temp at 9 a.m. is less than the temp at 3 p.m. No, my writing's not the best, so hopefully you can still see that. Okay, let's look at example 3 here. Solving for the independent variable. We have h of x equals, oh, sorry, that didn't copy too well. That's supposed to be 2/3. 2/3 x minus 5. Find the value of x for which h of x equals -7. Alright, so this time our x is not given to us. What's given to us is what h of x is. In other words, what the y is. So what we're going to do here is we're just going to put that in for the h of x. So -7 is going to equal 2/3 x minus 5. So now we just got to solve this equation just like we solve any other equation. We get rid of what's added or subtracted. So right now we're subtracting 5. Move it away from the variable. And we get -2 is equal to 2/3 x. And remember, when we're trying to get rid of a fraction, we always multiply by its reciprocal. Multiply by its reciprocal. Whatever you do to one side, we do to the other. 2's cross out, 3's cross out. We're left with x on this side. And the 2's cancel out. So we've got -1 times 3, which is -3. So x is -3. So h of -3 equals -7. So when x is -3, h of x is -7. That's basically what that's saying right there. But let's look at another example to see here. What about when we're graphing a linear function in function notation? So we want to graph f of x equals 2x plus 5. So one of the easiest ways to do this is a table. We're going to make up a table. Well, there's no fractions, so whenever there's no fractions, I usually just like to pick kind of some easy numbers, and I'll just do like -2, -1, 0, 1, and 2. Because this shows me what it does with negative values, 0, and positive values. So let's look here. When x is -2, so f of -2, we have 2 times -2 plus 5. Well, 2 times -2 is -4 plus 5 gives us 1. So our output is 1. How about f of -1? Again, 2 times -1 plus 5 equals -2 plus 5 is 3. So f of -1 is 3. How about f of 0? We have 2 times 0, which is 0, plus 5, which gives us 5. F of 1 is 2 times 1, which is 2, plus 5 is 7. And finally, f of 2 is 2 times 2, which is 4, plus 5, gives us 9. And I just have those filled into the table. Now we're just going to treat f of x the same as y. Our f of x is going to go on our y-axis. So you're just going to look at -2, +1, and put a point. -1, +3. 0, 5. 1, 7. And 2, 9. So when we graph this, if you notice, it's just a straight line going up, just like this. And we just put the arrows on both ends because its line's going to just keep on going. So this is the graph of the function f of x equals 2x plus 5. So now how can we use this in real life? So now modeling here with mathematics, the graph shows the number of miles a helicopter is from its destination after X hours on its first flight. On its second flight, the helicopter travels 50 miles further and increases its speed by 25 miles per hour. The function f of x equals 350 minus 125x represents the second flight, where f of x is the number of miles the helicopter is from its destination after X hours. Which flight takes less time? Well, let's understand the problem. You're given a graph of the first flight and an equation of the second flight. You are asked to compare the flight times to determine which flight takes less time. So we're going to make a plan. Graph the function that represents the second flight and compare the graph to the graph of the first flight. So the x value that corresponds with f of x represents the flight time. So let's solve the problem. So we've got our graph of f of x equals 350 minus 125x. I'm just going to make a quick table. And this time, though, I don't gonna put any negative because we're not going to be flying negative hours. So we'll just have 0, 1, 2, and 3. So, if I plug in 0 here, I've got 350 minus 0, which is 350. Put in 1, I've got 350 minus 125, which is 225. 350 times minus 125 times 2 is going to be 350 minus 250, which is 100. And 3 would be a negative 25. So let's plot our ordered pairs then. So we've got, I'm going to change colors so I'm not the same as the graph here. We've got 0, 350, which is of course the same starting point. Then I have 1, 225. I've got 2, 100. And at 3, I'm going off down below, so we can't really graph that. So if I'm going to draw this line here, okay, so I've now got the line drawn here, and now from the graph of the first flight, you can see that the f of x equals 0, x equals 3. But from our second flight, f of x equals 0, x is slightly less than 3. So the second flight takes a little bit less time. When you get done, go ahead and show me your notes and get started on your Clever assignment.